Analytical method, and I'm gonna show graphical method today. Graphically. Today you did graphical. Yeah, you did graphical and what? Or analytical.
No, sir, we only did analytical.
So that means I'm gonna show you a little bit of this. This method. Good. So in this part, these are the steps that you must know on the analytical method. On analytical method, these are the steps that you must know. Analytical method. So these are the steps that
That's one.
it's blurry. Is it blurry?
Yes, sir.
Or this, or this color that I'm using?
Yes,
Even now?
huh? Yes, sir.
Okay, let me get out and come back. Get out, get out, get out, get out. Hey, now it's saying join with the code. Rejoin. Rejoin. Tell me if it's blurred now. Is it blurred? What about now? Fine. Step number 1.
Yeah.
You must know the reactions, which is RL and what and RR. So, and then on this RR and RL, one needs to be what a vertical component, but a vertical component is determined by what? By the wind load, ne? Wind load. How do you see the wind load? You see the wind load like this. This part here, this one is a roller. These are the rollers, ne? So the wind load is this side. This is a wind load. That means this one is your RR, this one is RL, this one is your RR. So between RL and RR, which one is gonna be our vertical component?
It's RL.
Why?
Because there's a wind load and then it's what it has a resultant, it's excess resultant for which have the vertical and horizontal component,
I'm glad to hear that. Let's continue. Now, number 2, you have to find what the sum of a horizontal component, ne? Horizontal component, ne? When it's going to the right, it's positive. When it's going to the left, it's negative, ne?
Yes.
Good. Then after that, you'll find a resulted. Resulted is like a theorem of Pythagoras, whereby it's the square root of what? Of VC squared plus HC squared. What is VC? Is a vertical component, which is what? RL again. And here you will find the sum of that. And then after that, you'll find a direction. Ne?
Yes,
Direction. This direction is tan theta VC over HC. I'm like that, ne? How do you come to this conclusion? This is the first time to teach this thing. Like this skill. I've never done this. I go straight to other answers sometimes. Then this is what you have. You're gonna have something like this. So it's something like this. You have an angle of theta. Your VC is a vertical component. The horizontal component is that. So that's why we are saying opposite of adjacent. That's why we're saying this. You understand? I'm sure we are not allergic to mathematics. That's why we know that. Good. Let's continue. For now, I need everyone to do this. No, I need to do. Let's find what. Let's do the vertical forces. We are dealing with the vertical forces. Vertical forces, all of us. This Friday it will make me cancel my class. You cancel my screen. This is a new phone. It can't be blurry always.
it is.
So, okay, fine. Let me do this. What about now?
Too blurry.
Guys, I think we'll go back to Zoom here, to Teams here. I think it's time. Yeah, next we'll go to Team, because you can't be complaining about blurry for the first time. Gene. And don't say it's blurry. If you just say it's blurry, if you see nothing. You can't complain about blurriness while you are seeing something. What about now?
It's clear.
Aye, it must be clear always. Now we are dealing with the vertical component. What is vertical component? What is this formula for vertical component? It's a force sine theta. Get it?
Yes, sir.
And then we start with this one. I'm gonna show you. We're gonna change this force to have what a vertical component. So that means it's gonna be what? Number one is gonna be what? It's gonna be 40 sine what? What is the angle there?
Good.
What is the answer?
20.
We have 20 kilonewtons. This tells us that we have 20 kilonewtons. Ne? Then we come to this part. You see this one, this 35, this 35, this 35, this 35. This 35, it goes with this one, with this angle of 30. Now you see this one, like this. So that means the angle is what there? It's going to be what? You're going to change the angle there. It's going to be what? That means this tells you that you have what? Angle 30. You understand? It's like you have a Z, so you understand? So this angle there is 30. People are going to use their method. Don't take it from here to here. It's gonna be wrong, ne?
Okay.
So you're gonna have number 2, which is going to be what? 35 sine what? Sine 30, which is, I think it was 3-1 or something like that. What is the answer? It's what?
35 17,5.
It's 17,5. That one, it's gonna be 47. All right. Yeah, it's right. So that means this one, board. I'm changing it. I'm gonna put a color so that you can see. I'm gonna put it in the same spot here. But we know that from our beams, we know that if the forces are in the same position, we do what? We add them again. So that means here that means this tells you that you're going to have what? You are going to have 30 plus what is going to be 47,5 again. We are going to use that force. Our focus is going to be this one. Now we are going to do what? Horizontal component again. Horizontal forces. Horizontal forces, you're going to say number 1. You're going to have 40 cos what? Cos 30, which is this one. The angle is that straight. So you need to go this way. It's going this way, which is
34.64.
34.64 kilonewtons. Then you go to that one. You see, where is it going? The direction. I agree, this one is going this way. That means it's gonna go this way, ne?
Yes, sir.
So this one, it's sliding, it's going down. That means if we go to the horizontal, it's gonna this way, gonna go this way. So that means we're gonna have something like this, a force there. So it's gonna be what? It's gonna be, okay, you said 34,64. The number 2 is gonna be what? It's gonna be 35 cos 30, which is
30.31.
30.31 kilonewtons. So that means it's going to have what? 30.31 kilonewtons. Now, this tells you that this is a simple thing. Now you're going to have a beam, something like this. For you to understand more, you are going to have a beam like this. So you're going to have a beam like this. You're going to have that one, which is RL. you're going to have 20 that we have created, and then you're going to have somewhere. Okay, fine. Can you see with my ruler? I'm going to do this. I have to check something. I get this thing, it's into scale. I'm going to drop down this with a pencil when you're in the exam so that you can see something. I need to know from here to here. Last time I checked, I think it was I was having 0.9 plus 0.3 if I'm not mistaken. So you're gonna have that. What is the remaining distance here? It's 300. So it's gonna be what? From here to here, it is 0.3 meter, and then I think from here to here it was 0.9. I think 0.9 meter. Again, 0.9 meter plus 0.3. I think it's 1.2, ne? Is it 1.2?
Huh?
This,
Yes, sir.
yeah, okay, fine. So we are going to have that force that is going up. Now that means, now on this, that means, you see what I did? That's why I'm saying you must draw this into scale. I don't know if it's the same thing that you've done in class here, but this is my skill.
No, sir.
It's totally different.
It's different, sir. But then it do relate to this because you also do have that height, yeah. Find that height and stuff like that.
Okay, fine, then that's fine. And then we had a component that is going this way. A component that is going this way. And even this side, we have a horizontal component that is going this way. We have 34, what? 64. We have what? 30,31 kilonewtons. So listen to this, ne? Listen to this. So we have this 3.9. Listen to this. NB. We need to calculate the distance for what? For horizontal forces, ne? For horizontal forces, a supporting distance. So check something. We need to know from here, it's a height actually from here to here. You understand? It's like you are using a theorem, a soccer tour, ne? So the height, this one from here to here, you have a triangle here, ne? So you're gonna have what? What is gonna be? It's gonna be what? Opposite. It's gonna be like. It's gonna be what? It's gonna be 1016. It's gonna be what? Distance. What is the distance? The distance from here to here is gonna be what? Again, we have 0.3 and we have unknown one this side again. So it's gonna be what? It's gonna be 0.3 tan what? Tan 60 again. What is that? You understand what I did there? This is the Tesho. You don't know trigonometry. Tesho, you don't know the trigonometry.
Okay, something.
We have 60. We have 0.3 there. We don't know this one. Find h. Now you know. Oh, I know. So we're gonna have what? What is the answer when you punch here? I think it was 1 comma something if I'm not mistaken. 0.3 times 60.
Times 60.
Times 60.
160. 18.
What?
0.3 times 60.
Yes.
18.
18.
0.51.
Oh, I
or
was surprised.
0.52.
I said 0.3 times tan 60.
Oh, times 60.
0, what?
0.51.
Hey, that's what.
5.1.
Yeah, 5.1. Oh, that's what I remember. Something
Or
like that.
5.2.
So this
5.2.
one, 5.2, 5.2, ne?
Yeah.
So let's come. When we come to this one, you can see this one is 0 because the horizontal. There's no triangle that is formed here, ne? It's only the point here. You can see. If it was
Yes,
somewhere, obviously we're going to have a triangle somewhere. What? Yeah. Good. So now we know that the only for this one, it's gonna multiply with distance of what 0.52 meters. Regardless, let's check something. We are going to take number one. We are looking for the. Obviously, we know that we need this VC. We are not interested on this RR. Mara, we obviously will have to calculate both in order for just to check if it does balance. I get it. So we're going to take moment around what? Around RL. You calculate. Oh, RR. Calculate what? RL. Ne? So therefore, we're going to say we are going to rotate around RR, but calculating this. So we're going to take RL. You see RL, it's going like this, it's going like this, it's going like this. Then we check, do we have any other force that is going in this direction? Yes, we have this one, but this one, the distance is 0 because it's here. It does not have a triangle like this one. Remember? So it is going this way too, but the distance is going to be 0. So that means you're going to have RL multiplied by what? 1.2 equals to there's nothing. Ne? Then the other ones are going like this. Even this one is going like this. You can see most like in this direction. Eh? And this one is going like this. We have that. So that means we're going to say 20, which is this one, multiplied by 1.2 plus what? Plus 47,5 multiplied by 0.3 plus what? This one is going to be what? 30,31 by what? 0.52. That horizontal distance. Can I get my RR quick, please?
12 plus
Puleng left the group, ne? Puleng left the group, ne? Okay. No. Okay, it's fine. Can you fix that pic?
0.3 Kasikhundleka yini ifoni wena?
What is the answer? Kia?
I got 45,01. I don't know.
You got what?
45,01.
0.1 kilonewtons. That is our VC, we know, ne? That is our VC. So we are going to calculate what? Take moment around RL. We are calculating what? RR, ne? RR. So we're going to say our RR multiplied by what? 1,2. We have to check something. If we are rotating our, let's check something. This is our RR, so it's going to rotate around RL. Do you have any other force that is rotating around R? Yes, we have this one that is going this direction. Remember? This one, yes. That means we have two. So it's gonna be what? Plus what? 30, what? 31 by what? 0.52. We don't have another force. We're going to say equal sign equals to this one. These two are zeros because they're here. They're rotating around this point and it's there. You understand?
Okay.
So we're going to say what? 47, what 5 multiplied by what? 0.9. And then you take this one to the other side, it's going to be negative. That means we're going to left with what? We're going to say 47.5 by 0.9 minus 30.31 multiplied by 0.52. Everything divided by 1.2. What is the answer? Everything divided by 2.
And I'm trying to pay Kashem.
Maybe it's your network, is not even my network. Okay, is it blurry? Kia, is it blurry?
Yes, blurry, and then go back to normal like that. Yeah.
So can you please make sure that you fix your team, ne? We don't care who's complaining. Now on, we are going back to team. Next week, I don't want problem. Because teams does not lose quality. I get it.
Yes, sir.
Now is it okay or I should just leave or what?
It's not okay, sir. Let's see anything.
What is the answer, Kia?
I got 22.49.
22.49.
Yes, sir.
22.49. 20. Tesho uyaikuma.
Andle kusifonela.
Oh, okay. Wait. Awuboni chuma at all. Tisho wayemba. Wayemba kulukumba lo. Tisho, please. If you don't see it now, that means it's chive, or at last it's off.
Yingabi off. Seshinashibo.
Punch up here.
No punching. I'm trying to cancel 1 instead of 0.
So now we are fine, but we know, okay, you can just check. You are checking the vertical component only. Ne? You can, these horizontal, they don't affect the weight. These points load there are the one that are affecting the load. Ne? So you're going to say 20 plus this, 20 plus 47.5. What is the answer?
67.5.
So you got, and the other one you got what? 45.01 plus 22.49. You must get that one to show that your answer is correct.
67.5.
We are okay, so that means we can move. We are going to check the sum of what? Horizontal component. whereby we are going to check the first one, the first horizontal component is going to the right, which is going to be 34,64. We're going to say, and the other one is going to the left, which is what? Minus 30,31. What is the answer?
4,33.
4,33 kilonewtons. Therefore, you can calculate what? The resultant. The resultant is the square root of what? VC. What is our VC? We said it's the RL again. And then our HC is going to be this. Squared. What is the answer?
Um, 45,22.
45,22. So now we're going to direction. This is the last one. Direction is going to be it's going to be inverse of tan VC over what? HC. So you prostitute from that. You're going to say what? VC, what's your VC? VC is 45,01 divided by HC, which is what? HC, which is what? Which is, where is our HC? We calculated it somewhere there. It's going to be 4, what? 33. What is the answer?
Inverse of 10. 45,. 84,51.
84,51. So that is your angle, but you need to put in what? In degrees. Press. Do you know how to press degrees? Where you find something like this in your calculator? What is the answer? It's gonna be 84 degrees. What?
30 minutes.
14 minutes.
30.
30 minutes.
Huh? Yes. And then 18,03 seconds.
18 seconds. So now we have to check direction, because direction. So you check something. We have our VC that is going up like this. We have our HC that is going to the right like this. So you're gonna have, isn't like this direction. So you know, those who have done N3, like if you are having something like this, you have what? Equilibrium and resultant again. So now in result, what's gonna be the direction? Wait, what is that conductor? So now we're going to check this one. It's going to this way. Which direction is this one? If we have north, west, east, and south, what is the direction of that?
Northeast.
So that means your direction is going to be northeast. That's how you calculate it. We are done. We are done. Is there any question?